Good morning, one and all. Myself, Shivappa Pratham Shetty. I am teaching in one of the cbse school in Dharwad, JSS Public School, Kelgeri, Dharwad. So today I am going to teach a very important lesson. I think in cbse this will be the second lesson in chemistry, and at the same rate even in the state also it is a second lesson. So I think everybody knows about this very important and interesting topic, that is acids, bases and salts. So acids, bases and salts. Children, I think you might be knowing about the importance of acids, importance of bases and importance of salt in our day-to-day life. So everybody knows about acids. I think today we'll discuss a little about the topic, that is regarding introduction. What exactly mean by acid? What exactly mean by base? Okay, what exactly mean by salt? And we are going to discuss about the definitions of acids and bases, and even we are going to discuss about the second concept, that is indicators. Second concept, that is indicators. We are going to discuss about the indicators which are used in the acids, in identifying acids, bases and salts. And we are discussing physical properties of acids, and even we are discussing about the chemical properties. Chemical properties. Physical properties and chemical properties. So we'll take what acids, bases and salts means. So everybody knows acids. Acids which are used in our day-to-day life. I think lemon juice. Everybody knows lemon juice. Lemon juice has citric acid. We know that lemon has citric acid. Milk. Daily we drink milk. Milk consists of what? Lactic acid. Milk consists of lactic acid. And even to preserve pickles and all, we use acid. We call it as, especially we use in the name called vinegar. It is chemically called acetic acid. Acetic acid is used as a preservative. It is commonly used in to preserve the pickles and food, as a food preservative. It is acetic acid. Like this, we have many acids in our daily consumption. So, for example, I think oxalic acid. If you take oxalic acid, we'll take oxalic acid. Okay. Then we take citric acid. We take lactic acid. Many acids we used to take. Those are edible acids. Will not be that much harmful. Those are weak and edible, and those acids has got function in our body, and we need to take those acids. Okay. So today what exactly mean by acid, and the basic property, acids are sour in taste. Okay, acids are sour in taste. Acids are sour in taste. In Latin name acidus, it is actually derived from the Latin name acidus. It is derived from the Latin name acidus, which means that sour in taste. Which means that sour in taste. That is what we call it as acids. In acids, if you study this about acids in higher classes, say in 10th standard, another definition: acids are the one which gives H plus ion when dissolved in water. So we'll take example HCl. I think everybody is familiar with this acid, that is HCl. HCl, when it is dissolved in water, which gives H plus ion and Cl minus. So acids are the one which gives H plus ion when dissolved in water. That is about acids. Acids andre one which gives H plus ion when dissolved in the water. That is what we call as acids. So this is about the H2SO4. Okay, so on. Many acids are there. Some acids are strong, not edible. Some acids are edible. Okay, we people we take edible acids in our day-to-day life, and those are needed for the proper functioning of the body. So acids are very important compound, very important substances which we need to take in our food. Okay, that is for example, what happens if we are not going to take any edible acids? I think everybody knows about citric acid. Okay, citric acid, if it is not taken, it is going to cause some deficiency in the body. Okay, oxalic acid, if it is not taken, it is going to cause some deficiency in the body. Lactic acid, it is also very important, which we take it through the milk and curd, that is also going to do some function in the body. So those acids are very important in our day-to-day life. And these acids like HCl, HNO3 and H2SO4, strong acids which are used in the industrial level. Okay, in industries they are going to use this HCl, HNO3 and H2SO4. Okay, so that is very important. And Cl, I think if you look at the HCl, Cl is there, which is going to act very good disinfectant. It is used as a very good disinfectant. HNO3 is also used, strong acid. H2SO4 is also a strong acid. So the definition of acid goes like this. Acid is a substance which gives H plus ion when dissolved in water is called acid. Is called acid. Similarly, bases. Bases. Okay, acids. You came to know the definition. Bases are the one which gives OH minus ion when dissolved in water. For example, the familiar one NaOH, that is the sodium hydroxide. Everybody know about this. And sodium hydroxide when dissolved in water, what happens? It is going to give Na plus and OH minus ion. So the one which gives OH minus ion when dissolved in water is called base. Okay, and bases are the one are bitter in taste. Bitter in taste and soapy in touch. Soapy in touch. Bitter in taste. Okay, almost all the bases are bitter in taste, whereas soapy in touch, they are soapy in touch. I think in acids are the one sour in taste, but this one is bitter in taste, that is about the bases. So definition is, bases are the substances which when it is dissolved in water, which gives OH minus ion, that is what we call it as a base, and it is bitter in taste and soapy in touch. And that is why the property of acid and base are not same. It is different. The property of acid is different and the property of bases is different. So we have many, we can give many examples like sodium hydroxide, that is NaOH, potassium hydroxide, that is KOH. Okay, and like this we can give, and even we can give ammonium hydroxide, H4OH. Okay, these are the important bases which we use, and even the very familiar one, that is MgOH twice, which is used as a antacid. MgOH twice, that is a magnesium hydroxide, which is an antacid. I think when you get acidity, you will take ENO. ENO consists of magnesium hydroxide, which neutralizes the excess of acid produced in the stomach, which is a very good antacid, that is a magnesium hydroxide. Aluminium hydroxide, AlOH twice, all comes under the category of bases. So bases are important substances which we need in our day-to-day life also. So this is, and even because of this soapy touch, I think everybody knows, without help of sodium hydroxide and potassium hydroxide, or anyone, without help of anyone, you cannot prepare soap. Okay, I think everybody knows soap is slippery nature. So that nature is due to the sodium hydroxide, that is NaOH, and it is going to brings about cleansing action also. That is how sodium hydroxide and potassium hydroxides are used. And next is salts. So everybody know about this salts. Sodium chloride, we call it as a table salt or common table salt, sodium hydroxide. Okay, this is an essential part of our diet. Sodium chloride is an essential part of our diet. Like this, we have copper sulfate is there. Copper sulfate, sodium chloride. Many examples can be given to the salt. So this is a light introduction about the acids, bases, and salts. Acids, bases, and salts. Next comes the very important concept, that is regarding acids, bases, and salts, that is indicators. That is indicators. So what do you mean by indicators? I think everybody know about this. Vehicles, they will have indicators. What it will do? Indicators are one which indicate. For example, if you are moving to the left side, you will show the left side indicator. That indicates that you are taking a turn to the left side. So indicators are there to indicate. Here also the same thing. Indicators are the one which indicate whether the given sample is acid or base. So it helps in identifying whether the given sample is analyzing whether the given sample is an acid or base. So that is what we call as indicators. We have many indicators. We have natural indicators, and even we have artificially made organic means indicators also. So familiar indicators like litmus. I think even in lower classes also you studied about the litmus paper. Second one, that is phenolphthalein. Third one, that is methyl orange. Methyl orange. Okay, these are the familiar one. Even in board exams, like cbse board exams also, they used to ask questions on this. That is about litmus, phenolphthalein, and methyl orange. And even they will ask on this even in practical part also. Section B, they are going to ask about this litmus paper, phenolphthalein, and methyl orange. Indicators, first one will take litmus paper. I think everybody knows, even in 6th standard, I think you might have studied about litmus, how it is prepared. It is prepared from the lichen. It's a purple dye which is prepared from the lichen. Okay, lichen, you know the combination of algae and fungi. So litmus paper, I think you know there are two types of litmus papers. One is blue in color, we call it as blue litmus. Another one is red in color, we call it as red litmus. Red litmus paper. So if a sample is given to you, imagine if a sample is given to you, how to identify whether the sample is acid or base. Just take a blue litmus paper, dip into the test tube which consists of a sample. What happens if blue litmus changes to red? If blue changes to red, that indicates that it is the sample is acidic in nature. Sample is acidic in nature. Blue to red, that is acidic in nature. If red changes to blue, reverse, vice versa. Okay, the given sample is basic in nature. So this is the way that you can identify the sample whether it's an acid or base. With the help of a litmus paper, see, a small litmus paper will identify whether the sample is acidic in nature or basic in nature. This is one of the methods to identify the sample whether it is an acid or base. Next, very important, even this is one more important indicator which is commonly used in QC level also. Okay, in acid base titration they are going to use these two indicators. Phenolphthalein. So if phenolphthalein in acidic and neutral medium, it is definitely colorless. Okay, if you add this indicator phenolphthalein to the sample containing acidic in nature or acid, it will be colorless. If it is a neutral, if you add phenolphthalein, that is also colorless. But if it is a basic in nature, if the sample is basic in nature, if the sample is basic in nature, definitely it gives pink color. It gives pink color. It is going to give pink color. In acidic, it is acidic and neutral, it is colorless. In basic, it is going to be pink in color. Okay. Similarly, if you take methyl orange, it is in neutral, it is methyl orange, it orange in color only. But in acidic, in acidic nature, or in acidic medium, it is going to be red. In basic medium, it is going to be yellow. It is going to be yellow. Methyl orange, in acidic medium it is red in color. In basic medium it is yellow in color. This is about the indicators. So we have discussed three indicators. One is the litmus, second one is the phenolphthalein, third one is the methyl orange. Litmus, if it is added to the sample containing, if this added to the sample which is acidic in nature, definitely it is going to change blue to red litmus. If it is added to the what we call it as base, it changes red to blue. Blue to red adra sample acidic in nature. Red to blue, the sample is basic in nature. So phenolphthalein, when you take phenolphthalein in acidic and neutral, it is colorless. In basic, it is pink in color. It is pink in color. Methyl orange, when you look at the methyl orange, so it is right here. In methyl orange in acidic, it is red in color. In basic, it is yellow in color. So children, so these are the important indicators which are artificially made indicators and which we use in our laboratory, which we use in the laboratory normally. So these are the indicators which are used. Apart from this, we use natural indicators also. Apart from this, we use natural indicators. So natural indicators are red cabbage juice. Red cabbage juice. Next, turmeric juice. And even we know that one more important, that is olfactory indicators. Olfactory indicators. So this is separate category. Okay, this is olfactory indicators. So natural indicators like red cabbage juice and turmeric juice are the naturally occurring indicators. Okay, in red cabbage juice, okay, it is red in color. Red in color. In acidic medium, it is red in color. In acidic medium, it is red in acidic medium, it is red in color, and in basic medium, green in color. As red in color in acidic medium, in basic medium it is green in color. So this is how you can use red cabbage juice as also indicator, which is the naturally occurring indicators. So it is going to be red in color in acidic medium. In basic medium, it is going to become a green color. So that is about red cabbage juice. Next is turmeric juice. Turmeric juice and ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, ಏನಾದರೂ ಕರಿ ನಮ್ಮ ಶರ್ಟ್ ಮೇಲೆ ಏನಾದರೂ ಬಿದ್ದಾಗ, ವೈಟ್ ಕಲರ್ ಶರ್ಟ್ ಮೇಲೆ ಬಿದ್ದಾಗ, ಅದು ಬಿದ್ದಾಗ ಕಲರ್ ಎಲ್ಲೋನೇ ಇರುತ್ತೆ. ನೀವೇನಾದರೂ ಸೋಪನ್ನು ಅದಕ್ಕೆ ಹಚ್ಚಿ ವಾಶ್ ಮಾಡಿದ್ರಿ ಅಂದ್ರೆ ಎಲ್ಲೋ ಇದ್ದಿದ್ದು ರೆಡಿಶ್ ಬ್ರೌನ್ ಕಲರ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಹೇಳ್ತಾರೆ ಏನಂದ್ರೆ ಅದು ಬಿದ್ದಾಗ ಹಾಗೆ ನೀರು ಹಚ್ಚಿ ನಾವು ಇದನ್ನು ಮಾಡಬೇಕು ಅಂತ ಹೇಳ್ತಾರೆ. ಯಾಕಂದ್ರೆ ಇಫ್ ಯು ಅಪ್ಲೈ ಸೋಪ್ ಟು ದ್ಯಾಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಏರಿಯಾ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿಕಮ್ ರೆಡಿಶ್ ಬ್ರೌನ್. ಅದು ಒಂದು ಟೈಪ್ ಪರ್ಮನೆಂಟ್ ಕಲರ್ ಆಗಿ ಬಿಡ್ತದೆ. ಅದಕ್ಕೆ ಟರ್ಮರಿಕ್ ಜ್ಯೂಸ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ವರ್ಟ್ ರೆಡಿಶ್ ಬ್ರೌನ್ ಕಲರ್ when in basic medium. In basic medium it is going to change into what we call it as a reddish brown. But in yellow it will be yellow in the neutral and acidic. Color will remain same in neutral as well as the acidic. So this is what the very important concept, that is indicators. So indicators, as I told you, naturally occurring and artificially prepared indicators we have discussed. And one more thing, just now I told olfactory indicators. Olfactory indicators. In board exam every year they used to ask questions on this. Olfactory indicators means these are the indicators which have, these are naturally occurring indicators which have different smell in different medium. Like in acidic medium the smell will be different, in basic medium smell will be different. That is what we call it as olfactory indicators. Olfactory means sense of smell. Olfactory means a sense of smell. Best example you can take for olfactory indicators like onion, vanilla. Everybody knows vanilla ice cream. Okay, vanilla is clove oil. Vanilla, you should know about this vanilla. Vanilla, I think everybody have this. You had the smell of vanilla. Vanilla ice creams were very pleasant smelling ice creams. Okay, this vanilla in acidic medium, if you add acid like HCl, or if you add acid, the vanilla smell remains same. Vanilla smell remains same. But if you add NaOH, that is sodium hydroxide, this is what? Acid. This is base. Okay, if you add acid to vanilla, the smell remains same, no changes in the smell. But if you add NaOH to the vanilla, that is base to the vanilla, the smell gets suppressed. Smell gets suppressed, which means that the substance which behaves differently in acidic medium and in basic medium. If you add HCl, the smell remains same. If you add NaOH, the smell definitely it is going to suppressed. That is what we call it as olfactory indicators. We call it as olfactory indicators. So what we have discussed so far is acids, bases and salts. We have discussed about introduction and definitions of acids, bases and salt, and we have discussed indicators. That is we have discussed naturally occurring indicators and artificially prepared indicators, and we have discussed about olfactory indicators also. Okay, I hope you understood the lesson. Okay, thank you.